In this tutorial, we are going to solve a question which came in 2020, question B2 chemistry. The question reads, the following table shows information about some homologous series of organic compounds. Each compound shown is the second member of the homologous series. Okay, so some examples of families or homologous series which you can have are alkanes. We can also have alkynes. We can also have alkenes. Okay, so these are some of the families of the homologous series in organic compound. Now, there's a way on how you can easily be able to name any homologous series family. So the pattern which you follow is this. So if your homologous series family member is just having one carbon, so the name will start with meth. Okay, if it's starting with if it's containing two carbon, the name will begin with eth. If it's three, then prop. Okay, if it's four, the name will start with but. If it's five, the name will be pent. If it's six, it will be hex. 7 hept, 8 oct, and 9, just like that. Okay, so now based on this pattern and the families we've said, so the issue is the pattern is easy. When you are dealing with an alkene, you just, if it has one carbon, you just get the meth and you add these three letters, so it will be a methane. If it's an alkene, you add the three letter YNE to be a methine. If it's an alkene, you add the three last letters, it will be a methane. So you can apply this to everything, but our focus for this question, it will be on this one, since it is saying each compound shown is a second member of the homologous series. So from these families, they've gotten the second member, and from this pattern, our second member is going to have two carbon. So it is an if. Okay. So now here we go. So question A, copy and complete the table. Copy and complete the table. So the first row of our table, we are being told that it is coming from the family of alkenes. So what will be the UPAC name now, since it is having two carbon, because it is a second from the family members, so it is an if. Plus here I've said you add the last three letters, so we are going to have our ethene as the name of the compound. Ethene. Okay, then the displayed structure, all the alkenes obey the structure CnH N2 plus uh, plus 2. All of them obey this formula. So what will be the displayed structure if our number of carbon, because N here is symbolizing the number of carbon, is 2. So if I replace 2 there, I'm going to have C2H6. So our structure now will be a carbon bonded to another carbon. Now we have to know that carbon need 4 bonds for it to be stable. Carbon need 4 bonds for it to be stable. So this carbon have 1 bond, so it will need 3 more. So we are going to have a hydrogen here, another hydrogen here, and a third hydrogen here, because 4 bonds is okay. Then the other one also will have 4 bonds. So there is 1 bond there. We are going to have another bond here. We are going to have third bond and a fourth bond. So that's the structure of ethene. Okay, then in the next row, we have been told that our UPAC name here is an ethanol. So ethanol, it's ending in OL. So wherever you find an organic compound ending in OL, just know that this is an alcohol. All the alcohols end in OL. Okay, so being an alcohol, it is going to be an ethanol. Okay, so the family or the homologous series where ethanol is coming from is an alcohol. Then what is the proposed structure? alcohols obey this formula: CnH N2 plus 1, then with an OH at the end. That's the formula which all the alcohols will obey. So if we have 2 carbon, we are going to have C2H. So if I replace 2 where there is carbon, we are going to have 2 by 2, 4 plus 1, 5. So we're going to have C2H5 and an OH. Okay, so what will be now the structure for this one? Since we have come up with a molecular formula, it is now easy for us to derive a structure. So the structure will go like this. We are going to have a carbon bonded to another carbon. Then remember, carbon needs 4 bonds for it to be stable. So since there is 1 bond here, we'll have another bond, a third bond, and a 4th bond. This one is okay. Then the other one bond here, another bond here. So all the 5 hydrogen has been utilized. So we are just remaining with the OH here. So this is the formula for ethanol. Next, the third row, we have the structure here. So from the structure, I want you to focus on this part. This part will tell us the family from which this compound came from. So this part is COOH. Wherever you go, you find COH, just know that this is a carboxylic acid. It is a carboxylic acid. So the homologous series from which the compound is coming from, or the structure is coming from, is the carboxylic acids. That's where it is coming from. Okay, then the formula, we are going to have C bonded to another C, then hydrogen here, another hydrogen here, another hydrogen here, then 1 oxygen here, double bonded because oxygen, then 1 oxygen here and a hydrogen here. This is because all the carboxylic acid follow the formula CnH N plus, or you can just say OOH. So all of them obey the formula CnHnOOH. Sorry, there is a 2 omitted here. Okay, CnH2n, then OOH. All of them obey the formula. So you can see that the formula is applicable there. Okay, so we move on to the third one, which says the third member in the family of alkenes. The third member in the family of alkenes is isomeric. Draw 2 of the isomers and give the UPAC name of each isomer. Draw 2 isomers and give the UPAC name of each isomer. Okay, the family which our third member is coming from is an alkene. Okay, so what we have to know about alkene is that they are unsaturated hydrocarbon, meaning that they have at least a double bond somewhere. So if it is from the third member, we know that position number 3, the name will begin with prop. Then adding the 3 letters, we are going to have pro, okay, propene. So propene, we know that it's an alkene, at least having a double bond somewhere, because all the alkene are unsaturated. So we can have the first one, which is C, double bonded to another C, then another C. So carbon, to satisfy the octet rule, it will need 4 bonds. So we have 2 bonds, we need 2 more bonds for the octet rule to be satisfied. Then the one in the middle, it has 3 bonds already, so we just need an extra of 1 for us to satisfy the octet rule. Then the terminal carbon just have 1 bond, so to satisfy the octet rule, we shall need three more bonds. So second bond, third, and the fourth one. So this is the first isomer. This is the usual propene. Okay. Then in the second one, you can just shift the position of the double bond. So let me do it like this. Carbon, instead of me putting the double bond here, I'll shift it on the other position. So we are going to have a double bond this side, then the third carbon there. So following the octet rule, this one need three more bonds. So a hydrogen, another hydrogen, then a third hydrogen. This one already has three bonds, so following the octet rule, just one hydrogen there. Then the terminal one has two. We need two more hydrogen to be stable. So we can say that these structures, their chemical formula is the same. They both contain three carbons and 6 hydrogen, because all the alkenes obey CnH2n. So this structure, the first one and the second one, both have 3 carbon and 6 carbons, but the orientation of the atoms in space are different. You can see the location of the double bond in the first one and the location of the double bond in the second compound. This one is on carbon number 1, but here the double bond is on carbon number 2. So that's what they mean when they say isomers. Isomers, these are compound with a similar chemical formula or molecular formula, but different structural formula, or in simpler terms, difference in the arrangement of atoms in space. So this one now will be named according to UPAC. You have to indicate exactly where the double bond is. So since it is on number 2, so this one will be 2 propene. This one, since it's on the carbon number 1, there is no use of us indicating that it's on 1, no. But here, since it's on carbon number 2, you indicate to say it's on 2 propene. So these are the two isomers which the question was asking for. The last question says the formula C2H4O2 generates two different compounds A and B. The formula C2H4O2 generates two different compounds A and B. A is sweet smelling while B chalk. A is sweet smelling while B chalk, but react with sodium bicarbonate to produce carbon dioxide. Identify A and B by their structures. Identify A and B by their structures. Alright. So when you are dealing with organic chemistry, wherever you see a compound which is sweet smelling, just know that this is an ester, because esters are the one which they use in forming these deodorants, the perfumes and whatever. So wherever you see the characters like sweet smell, what should come in your mind is that they are talking about two esters. So A already one can say it is an ester. Then B, they are saying it chokes but react with sodium bicarbonate to produce carbon dioxide. Sodium bicarbonate is a base, so the reaction of sodium bicarbonate, calcium carbonate with an acid will always produce a salt and the carbon dioxide. So B, one can also tell that it's an acid based on its nature of reaction and also its property of choking. Some they say it's sour. All those are the properties of carboxylic acid. So based on those truths, we'll say A. Compound A is an ester, while B is an acid. Okay. So identify A and B by their structures. Okay, so what they have in common is the molecular structure. The molecular structure, or that are the structure of the molecular formula, I mean. So the molecular formula is the same. They want us now to identify them by drawing their structure. Okay. So you provide the structure. The molecular formula we've been given is C2H4O2. Okay, so now since we've said A is an ester, what kind of an ester is this with two carbons? And what kind of an acid, since B is an acid, what kind of an acid is B with the two carbon? So for an acid with B, it's an ethanoic acid. We named it already in the table there, and we know that acids will obey the formula CnH2 CnHn CnHnOOH. Okay, so that's the formula which the acids obey. Okay, so let us start with our acid, which is B. So B is ethanoic acid. Okay, it's ether. Our B is our ethanoic acid. Okay, so now the structure for our ethanoic acid will go like this: C bonded to another C, since we just have two carbons from our molecular formula there. So following octet rule, we are going to have H here, another H there, another H here. Then this one, we have two oxygen, so one oxygen double bonded to carbon, so carbon need one more bond to be stable, so one bonded to oxygen, then another hydrogen there. So this is the ethanoic acid. This is our B, which is ethanoic acid. Then our A is an ester having two carbon, an ester having two carbon, so it will be a methyl methanoate. Because all esters end in methanoate, all esters end in O8, like that. So now drawing the structure, we're going to have our C bonded to another C. Okay, then hydrogen, another hydrogen here, satisfying the octet rule, another hydrogen. Then this side we are going to have three, we are going to have oxygen here, then another oxygen, like that. Yeah, that's our ester, ethanoate. Okay, so that's what this question was all about. Thank you very much for the attention.